This prepared presentation analyzes an 8th grade science learning module. The target audience for this presentation consists of a broad range of professionals in the education field, whether new or experienced. Educators and future educators of all disciplines can benefit from this presentation in regards to in-course correction. The target audience for the course being assessed and improved is K-12 education, more specifically a group of 20 8th grade students in a science classroom. The students that participated in the course were both male and female and ranged in age from 13 to 14 years old. The audience was a very diverse group, including gifted and talented students, English language learners, and students with special needs. Specific student learning needs are outlined in each student's IEP or 504 plan. All students are working with a one-to-one initiative using MacBook Airs in a blended classroom. The students have prior knowledge experience in the science classroom, completing investigations and working with materials to construct new knowledge. A class of 20 8th grade students participated in a chemistry course from March to April during the 2016-2017 school year. This is the first year implementing a new curriculum in alignment with the next generation science standards. The course is focused on kinetic energy. Students explore expansion and contraction of solids, liquids, and gases through completion of various tasks and activities. Analyzing data from the course has revealed both strengths and weaknesses of the students and the course. Through analyzing participation and grading, it has been identified that despite students' efforts, there are 2 struggling students, in specific, who tend not to participate in activities. When these 2 students choose to participate, they score below average. In order to increase student achievement, in-course corrections will be made accordingly. In order to assess student achievement, the overall effectiveness of the course data has been collected. Research has been completed, and data will be continuously analyzed to enhance the course to meet learners' needs. The constructivist theory and the ADDIE model both support the activities and tasks within this course. Constructivism encourages construction of one's own knowledge and through experience and reflection. The activities in the course foster student participation, collaboration, and engagement. The ADDIE model was the instructional systems design framework that constructed the creation of the course with the phases of analysis, design, development, implement, and evaluate. This model was well suited for the course considering its flexibility. The course corrections that needed to be made were easily implemented because of its flexibility. The course's main focus is on the kinetic energy theory. In the course, students will explore expansion and contraction in regards to solids, liquids, and gases. The course was broken down into 3 goals. The goals were to explain the phenomena of expansion and contraction in solids, liquids, and gases. Course objectives were created to be SMART, meaning they are specific, measurable, attainable, relevant, and time-bound. The objectives are student-friendly and outline the expectations students should be able to meet after completing the tasks and activities. The tasks and activities in this course were carefully planned to meet the needs of learners. Students' learning styles and needs were considered greatly. There is a combination of verbal, visual, and hands-on assignments to keep the students engaged and motivated. Based on student preferences, small group, large group, and individual assignments have been included. To meet Objective 1, students will be given materials to build a model. They will be challenged to collaborate with their lab group to plan, design, and create a successful model of heating and cooling air. Students will have the supplies to create several different model options. They will also follow procedures to complete a lab investigation. The results of the investigation will then be analyzed so they can be used as evidence to explain how air expands and contracts when it is heated and cooled. Students will also edit their original model and write an explanation to explain what happens to air as it is heated and cooled. The lab groups will present their models and leave a written or visual model up for a gallery walk after the presentations. The students will leave comments and ask questions at the stations during the gallery walk. In order to meet Objective 2, students will view a bottle thermometer demonstration and then create their own version to conduct an investigation on heating and cooling water. Lab investigation questions and a class discussion will follow. Students will also observe several different kinds of thermometers in hot and cold water. They will apply what they know about expansion and contraction to create a video presentation for third grade students about how a thermometer works. In order to meet the goals for Objective 3, students will observe the ring and sphere and make predictions of what will happen when they are heated and cooled. Students will witness the sphere being cooled and the ring being heated. Based on this experience, they will draw a conclusion about what happens to solids as they are heated and cooled. Finally, students will identify an example of gas, liquid, and solid expansion in their everyday lives. They will make a concluding statement connecting solid, liquid, and gas expansion and contraction. The Next Generation Science Standards practices consist of strategies and behaviors that students should participate in as scientists. These practices require skills and knowledge. Strengthening students' abilities to complete the practices should enhance comprehension and comfortability within the science field. All practices are present within this course. To assess the overall course as well as student achievement, both formative and summative approaches to assessment were conducted. Formative assessments were used to guide practice, adjust instruction, check for understanding, and to guide future instruction. Summative assessments monitored student progress and achievement while also evaluating the course. Assessments in combination with observations, surveys, and interviews created a great amount of data to analyze. While collecting data, ethical considerations were of high priority. Students were aware data was being collected and were mindful of the purpose for the collection. Students' confidentiality is considered greatly when analyzing and interpreting this data. During the course corrections, materials were only chosen once they were deemed safe and appropriate for the audience. The data collection needed to be analyzed fully to determine why students were not performing and meeting expectations of the intended engagements. The data collected was used to update data walls that have been tracking students' progress over time. When struggling students were identified, the team of teachers collaborated to adjust and modify the course to meet the students' needs. Strategies and tools were shared and discussed to determine which were most appropriate for these specific students. Aside from the clear data from the course, students' absences, past grades, learning styles, motivation, and home life were revisited to understand the big picture further. Finally, a discussion occurred to find a correlation between the time spent on activities and the level of success reached. The first set of data displays student performance, broken down by objective. Students performed best on Objective 2. Objective 2 consisted of a lab and an explanation. I think students performed better on these assignments because of the dynamics of them. There was a video which served as a model and directions that students watched prior to completing the lab investigation. Then, students were able to explain what they observed after completing an interactive activity. These two assignments seemed to fit the needs of most learners. The modeling and repetitive practice seemed to work for the students. Objective 1 was tough because it required students to problem solve and create a model with no prior knowledge. Students may have benefited more from this activity if it was later on in the course rather than the first assignment. Providing a scaffold for the assignment would also be helpful for struggling learners as it is a challenging assignment. Objective 3 was difficult for students as they were required to draw conclusions from observations and then connect all knowledge they have constructed thus far. Making connections is difficult, and breaking down information and providing sentence starters may help students guide their responses. Additional data was collected and analyzed concerning students' thoughts on the learning outcomes, accuracy of content, student satisfaction, significance of material, and methods and presentation. Students rated each statement from 1 to 4. Students' feelings were mixed but gave the most positive results relating to interactive activities and course navigation. Finally, a course reflection and satisfaction survey was analyzed. Though students' attitudes seemed to be positive, the survey revealed insights into areas of strengths and weaknesses. Students were honest with responses that a majority did not completely read and follow directions, asked for help when they needed it, and did not apply themselves fully in each assignment. From this set of data, it is also clear students may need more time to complete tasks and could benefit from more real-world applications to help them find the content interesting and relatable. It would appear from the students' feedback that they responded well to a task that had been designed to incorporate the characteristics of authentic assessment. The data shows that all Not all students are reaching their maximum potential, and therefore changes need to be made. Struggling students are performing below average, while excelling students seem to be satisfied with the challenge of the course. Differentiation and scaffolding of assignments and activities seems to be necessary throughout the course. The current achievement gap is too large to consider the course successful and effective. In order to lessen this gap, adjustments will be made. In order to improve all students' learning experiences, adjustments will be made in relation to learning styles, delivery, learning activities, testing formats, and module structure. There will need to be an increase of formative assessments to drive instruction based on the needs of the learners. Improving the assessments should help in remediation and enrichment within the course. As an integral component of the education process, assessment supports learning by providing learners with the opportunity to demonstrate acquired skills. Based on the data presented, considerations to improve the course were suggested. Implementing strategies to meet students' learning styles would be beneficial. In this case, increasing student and teacher communication will be extremely valuable. There are multiple observations made throughout the literature on ways to support meaningful learning and teaching for understanding that highlight the importance of scaffolding the learning process and providing constant feedback to students. Opportunities for feedback from peers and instructor will be increased to increase student comprehension. Instruction clarification will also be necessary. Directions will be broken down into simpler steps and expectations will be outlined with provided rubrics. The rubric should allow students further support in understanding expectations. The course is full of higher level skills in the application field. Providing scaffolding and guiding connections between material would be helpful. Students seem to understand the information in isolation, but have trouble making the necessary connections. Increasing the variety of testing formats would be in the best interest for the 21st century learners. They have more options than ever to apply themselves. Determining the ways each student is able to express their knowledge best is important. In the science field, I find students need to learn to be strategic and creative problem solvers. Struggling students are not generally strategic thinkers. Therefore, teaching them these skills through modeling would allow them to further succeed. Modern society has been transformed by the availability of technologies in everyday life. In order to enhance learning of students and equip them for the future employment, educational institutions are embracing a hybrid teaching and learning approach that complements face-to-face teaching with online materials. Course corrections were necessary to ensure the course is of high quality and effective for all students. Thank you for watching this presentation.